Hey Gordon!
Yo, what's up?
What are we doing, man?
Oh man, I just crashed.
I thought we were supposed to do an epic video. Epic CPU video. What are we playing games for, man?
Well, because you were late, so I had to entertain myself by playing Need for Speed Heat. Yes, we are going to do an epic video. And if you want to know where the epic machine is,
This black guy over here. So, want to know more? Watch the end of the video to find out what's so epic about this epic video. Instead of now telling you who our user is for, first thing you see is big black box. It looks very black and nothing, right? Gordon, please show the whole world what's so special about your big black box.
yes, while I leave my BMW M3 on the screen, let's take you through as to what's powering this whole thing. So the first thing that strikes you about this set is it's green. It's really green.
And black.
Green and black.
Sound like a Bruce.
More like a bush actually. Anyways, you're probably wondering who are these two over here. These are 4U CPU coolers, which is why they look shorter than a lot of the other tower coolers. They're actually designed to fit inside a 4U rack mount chassis. What's sitting right underneath? In this case, we have two pieces of the EPYC 7302 16 core, 32 threads. 16 core, 16 core, so we have a total of 32 cores, 64 threads here over here. So flanking the two CPUs, we have RAM. Lots and lots and lots of RAM. We have not 16 gigs of RAM, not 32 gigs of RAM. We have 512 gigs of RAM. Yes, my friends. This monster over here has more RAM than a lot of desktop PCs out there have for flash storage. So we have 4 sticks to the top, 4 sticks to the bottom of the CPU. The second one likewise also has 4 to the top and 4 to the bottom. Each of the sticks is 32 gigs. 32 times 16 equals to 512 gigs of RAM. So you have 32 cores, 64 threads, 512 gigs of RAM. So if we move right down, we have the Radeon Pro WX 7100. This particular model here has 8 gigs. It's specially designed for applications such as AutoCAD, Maya, etc. If we were to move right down, we have a 1TB Samsung 970 Pro PCIe, or we'll call it NVMe SSD. For secondary storage, it has HDST UltraStar 6TB drive over here. All of this is connected to the Supermicro... I forgot what's the name of this motherboard again. I only know it's got 2 sockets here. Ah yes, it is the H11DSI-NT. Yes. Supermicro, please come up with better names. That was a lot to remember. What is so remarkable about this motherboard? Well, you'll notice one thing about this board. It is massive. And when I mean by massive, it takes up almost the entire length of the I/O tray of this Fantech N2 Pro chassis. And this chassis, by the way, is no small fry. It's one of Fantech's full tower chassis. It needs all this room to be able to fit both the CPUs as well as the 16 slots for the copious amount of RAM that's sitting inside here. For ventilation wise, we have a 140mm fan to the back as well as a big gigantic 200mm here to the front. That pretty much takes you through as to what this set comprises of. Okay, now let me get into who the customer actually is and what a machine like this could probably be used for. So, you may probably be wondering, why would anybody want a machine like this? Well, it turns out that there are quite a couple of uses for machines such as this. For one, I'll start with the company that commissioned us to build this machine. Again, it's probably to no surprise to anybody by now, it's AMD Singapore. But I don't know what the boffins over there are doing, but they just asked us to build this thing. The only clue that they kind of left us was they were going to do circuit analysis and design with it.
Yeah, the 950X is not enough. You need 2 more EPYC CPUs.
Apparently for the guy who's going to be using this machine, normal Ryzen and Threadripper just does not cut it. Feedback that we got from him was he needed this amount of RAM, and there are very few platforms out there that can support this amount of RAM. AMD Ryzen 3rd Gen supports up to 128 gigs of RAM. That is if you populate it with 4 sticks of 32 gig. Threadripper supports up to 256 gigs of RAM, which can be done with 8 sticks of 32 gig. How much RAM does EPYC support? This is where things really go crazy. For this example here, we have 16 sticks of 32 gig. AMD EPYC on the other hand has support for all the way up to 256 gig RAM modules. So in theory, you could populate this board with 256 gig times 16. Let me do the mathematics in my head.
Do you have a calculator in front of you?
Oh yes, we have a calculator! What the bloody hell! Yes, so 256 gigs times 16. You could go up to
4.1 terabytes of RAM.
yes, 4 terabytes of RAM. We also know that EPYC goes way up to 64 cores. If you were to fully kit out this machine, you will have a theoretical total of 128 cores and 4 terabytes of RAM. What would anybody want all that kind of bloody horsepower for? Well, it turns out that there are many uses for this kind of CPU horsepower. First and foremost, virtualization. Now, what is virtualization? Think of it this way. For a machine with this many cores, you could subdivide the cores and run multiple, what we call instances of an OS. So let's say for this machine, we have 32 cores. You could probably devote 4 cores to, let's say, a web server, another 6 cores to say maybe your enterprise ERP server, and so on and so forth. This is what we call in this industry as a consolidation. Instead of having multiple machines each doing one job, we have one doing many things. With each instance, however, you do need RAM to go along with it. Let's say you have devoted 4 cores to your web server. Now naturally, you have to give that guy 32 gigs of RAM, for example. Then maybe the ERP server, you probably give it 6 cores, and because this guy's maybe his workload is a lot heavier, yeah, give him 64 cores. Then maybe you start another, maybe your email server, you give him another 4. Now this guy is also gonna need RAM. Let's give him 16, for example. So as you can see, as you have more and more instances in the machine, the amount of RAM that you need piles up quite a fair bit. That is the main reason why for server class machines such as this, you need this ridiculous amount of RAM to go along with it. What I have here is Hyper-V Manager. Now, Hyper-V is what we will call a hypervisor. This is built into Windows 10 Pro, by the way. Windows 10 Home does not have this feature at all. If you want Hyper-V, you have to upgrade to Pro. What does a hypervisor do? Well, it allows you to run what is known as virtual machine instances or virtual machines. What is a virtual machine? Think of it as like the Russian doll concept. You have a doll inside a doll. So in this case, we have installed 2 instances into this set. One being that of Windows 10 Professional, the other one being Ubuntu Desktop 18.04. You see right there on the front, this is my task manager. I have 32 cores, 64 threads as shown here. If you go to the virtual machine, my Windows 10 Pro virtual machine has been given 8 cores, and out of the 512 gigs of RAM that this entire machine has, he has been given 32 gigs of RAM. And on the second virtual machine instance that I have, Ubuntu, so you can see right over here, for Ubuntu, I have also given him 8 CPU cores as well as 32 gigs of RAM. You may probably be wondering, why do you want to do this? Now, virtual machines can be very useful to people who are doing software development, for example. Let's say they are doing their development on the main machine itself and they want to be able to test it on different OS. So in this case, your host is running with 10 Pro, but you have a VM running Ubuntu. What you can probably do is you can run your software on Ubuntu as though as it's on a separate machine running Ubuntu 18.04. Instead of having get a second machine or having to configure this machine for dual boot, you have Ubuntu as a virtual machine instance, which makes things a lot easier and less complicated for the software developer. The other way that which this can be utilized, and which is the much more common use of virtualization, is that in data centers. Now in data centers, let's say you need 4 cores for a web server. They don't give you a physical machine with 4 cores and let's say 16 gigs of RAM. What they do is that they take a server class machine like this, right over here, and what they do is that, okay, right, you need 4 cores, so we'll give you a virtual machine instance with 4 cores. And you need 16 gigs of RAM, we'll give you 16 gigs of RAM and we'll charge you for that 4 cores and 16 gigs of RAM. This opens up a lot of possibilities to the client, the person who needs this kind of server instances and services. Let's say today he utilizes 4 cores and 16 gigs of RAM. But then maybe in the near future he says, hey, you know what, I think maybe for today I need 8 cores. I need 32 gigs of RAM. Maybe he's expecting more traffic to the web server of his, so he can scale up and pay more for that increased amount of cost as and when he needs. And he can therefore after that also scale down when he no longer needs that kind of... It gives more flexibility. The other advantage of this is that all these virtual machines you see here on the screen exist as either one big folder or one big giant image file on the host OS itself, which makes the task of backing them up so much easier. So let's say you have something that you want to test. Does it run properly on on Windows 10, will it screw up my clients or my company's machines running Windows 10? You don't want to test that on a live actual machine. The best way to go about doing this is to probably test it on the virtual machine here instead of the host. In case anything goes wrong, the only thing that's affected is the VM instance itself. If this screws up and the host is okay, that's okay. You just recover back from a backup of this VM instance before that error occurred. If you don't have something like this, what you'll probably end up doing is that you test it on your Win 10 Pro machine and it's like, oh crap, now my Win 10 doesn't boot at all. Probably ending up in the situation that you have to reinstall your Windows, your application. Not a very nice thing to do, but if you use a virtual machine to test, all you have to do is cover back the virtual machine from a backup or just create another new virtual machine. Fun little fact, those Android emulators like BlueStack and Nox, they're also virtual machines. Except that in this case, they are a virtual machine instance running Android inside your Windows 10 machine. So for those of you who play mobile games such as Girls Frontline, I had this one customer who bought a Threadripper from me. With 16 cores, he devoted 8 cores to Nox to run Girls Frontline. Yeah, you know who you are. My very first Threadripper customer, and all you do with it is you run Girls Frontline. I hope the girls are pretty.
Thank you to Gordon again for this amazing lecture education about virtualization. EPYC does very well with virtualization. So if you want to run a lot of instances on your machines, you don't want to have so many computers at once, make sure you check out AMD EPYC and virtualization. So such a machine doesn't come cheap naturally. If you ever want such a machine, make sure you contact me or contact Gordon at Typhoon Systems.asia. So the link is below in the description box. Check him out, he does amazing machines. Next, we have a lot of new projects coming on. I introduced you to the rack the last time. It's over here. It's going to be one of our next videos, so make sure to check out our channel again to see how this rack looks and I can explain to you the whole thing about servers. So in the meantime, if you like this video, give me a thumbs up, definitely give me comments, comment sections, and very important, make sure my channel goes well. So check out my AMD playlist, my Asus playlist, and my other playlists. So this 2020, we have a lot of new projects coming around, so make sure to check out back to our channel to see what we have in store for you guys. So on a final note, make sure to click on our icon to subscribe to our channel, click on the bell to know when we put up new videos. So from Gordon and I, out. Bye bye.